In section 2.4 and 2.5, I've combined them together because they're talking about chemical reactions, and it's talking about enzymes and catalysts, which are proteins. So bonds are going to break and form during chemical reactions. Chemical reactions change substances into different ones by breaking and forming new chemical bonds. Reactants are changed during a chemical reaction. Products are made by the chemical reaction. So again, bond energy is the amount of energy that is going to break a bond. Energy is added to break bonds. Energy is released when bonds form. A reaction that is at equilibrium when reactants and products form at the same rate. So right here, you see that you've got carbon dioxide and water is going to form that. Activation energy is the amount of energy that needs to be absorbed to start a chemical reaction. So right here you can see that you need to have the energy get to that level in order for the chemical reaction to start. So again, here's a guy rolling a ball up the hill. Once it gets to the top of the hill, he's reached the activation energy needed for that to take place. Exothermic reactions, they're going to release more energy than they absorb. So reactants have higher bond energies than products. Excess energy is released by the reaction. So that's what you end up seeing here in this picture, is this is an exothermic reaction. So again, exothermic reactions, they're going to release more energy than they absorb. Endothermic reactions absorb more energy than they release. So reactants have a lower bond energy than the products. So the exothermic, it's going to be giving off heat, basically. Endothermic, it's going to be taking in heat. So, energy is absorbed by the reaction to make the difference. So right here is an endothermic reaction. So in section 5, we're going to look at enzymes, which are catalysts for chemical reactions. So a catalyst is going to be a substance that speeds up a chemical reaction. It's going to make it happen quicker. So it's going to decrease the activation energy and increase the rate of reaction. So you can see where you had to get to on this with just the normal, and having a catalyst there, it decreases the energy that's needed for that chemical reaction to take place. So enzymes allow chemical reactions to occur under tightly controlled conditions. Enzymes are catalysts in living things. So enzymes are nature's catalyst. So enzymes are needed for almost all processes. Most enzymes are proteins. So if you have a disruption in homeostasis, so that balance that's within a cell, it can prevent enzymes from functioning properly. Enzymes function best in small range of conditions. Changes in body temperature and pH can break hydrogen bonds between the different structures in the protein. An enzyme's function depends on its structure, so if it changes shape, it's not going to be doing what it needs to. An enzyme structure allows for only certain reactants to bind to the enzyme. So those reactants, you've got their substrates, and you've got the active site. So, you can see up here the substrates, and then here's the enzyme, and they're going to end up catching there, and that is going to be the active site. It's referred to as a lock and key model to help illustrate how enzymes function. If it doesn't have the right substrate to act on it, it's not going to function. And so it's just like if you go up to a door and it's locked and you don't have the right key, it's not going to work. So substrates are going to be brought together. The bonds in the substrates are weakened. So you've got the substrate. It's going to bind to the enzyme in a certain place called the active site. The enzyme brings the substrates together and weakens their bonds. And then the catalyzed reaction forms a product that's released from the enzyme. So that's the end of the notes for Chapter 2, and that's the end of the 2.4 and 2.5 notes.